In this video, we're going to be in 14.3, and we're going to talk about how to find the least common denominator of a list of rational expressions. So these problems will be like those from 14.3, numbers 21, 23, 25, 31, and 39. Our first list of rational expressions is going to be 14 over 3x and 16 over 27x to the second. As long as we can't simplify anything, we're not too interested about the numerators to start off with. So I'm interested in this 3x and this 27x squared. My LCM, which is what I'm going to use to get my LCD, but my LCM here for these, that this is 3 to the first, x to the first. This is 3 to the third times x to the second. So I'm going to have to be greedy and pick which one I'm going to take that has the highest exponent from the common bases. So my LCM here is going to be 3 to the third times x to the second, which just so happens to be 27x to the second. That's my LCM or my LCD here. So that's going to be 27x to the second, that I can multiply this one here by 9x over 9x and get a common denominator of 27x to the second. Here I don't need to multiply by anything to get that common denominator. We're not asking you to do that, but I'm just telling you that's going to be the process here, as you multiply by what's missing to be able to make the common denominator. So the LCD is 27x squared in the first problem. Now let's look at 9 over 8x and 1 over 4x plus 4. So I'm going to have to look at this in factored form. 8x and 4x plus 4. That this is 4 times 2 times x, and this is 4 times x plus 1. I'm leaving the 4 out there because I saw that that was the greatest common factor. So my LCD is going to have to not only have the 4, but it's going to have the 2, and it's going to have the x, and it's going to have the x plus 1. So this is going to be, let's actually write it this way. So this is 2 to the third, and this is 2 to the second. Because those had a common base, I almost made a number that was too big. So I only need 2 to the third as my factor in my LCD for the 2's. So this is going to be an LCD of 8x times x plus 1. I would leave it in factored form like that, but if you want to multiply it out, it's 8x squared plus 8x. All right, so let's go ahead and clean this up a little bit. Let's look at number 25 here, 5 over x plus 1, 7 over x minus 3. So our LCD is just going to be x plus 1 times x minus 3, because we don't know what they are since we don't know what x is. We're just going to have to multiply them together. We can leave it in factored form, but if you want to multiply that together, it's going to be that. I'd leave it in factored form. It's going to be most helpful for you to do that, unless the problem tells you to do otherwise. 13 over 6x plus 6, 7 over 2x squared plus 4x plus 2. Six times x plus 1 over here. 2 times x squared plus 2x plus 1 is 2 times x plus 1 squared. So my LCD. Let me break this down a little bit more. This is 2 times 3 times x plus 1 is going to be a 2 and a 3 and an x plus 1 squared. 6 times x plus 1 squared, or 6x squared plus 12x plus 6. All right, one more here. 1 over x squared minus 4 and x plus 9 over 3x to the 5th minus 6x to the 4th. This is x plus 2, x minus 2. This is 3x to the 4th times x minus 2. So we're going to need an LCD of 3x to the 4th, x plus 2, x minus 2, so that all of our factors there are represented. All right, so that is, those are our examples for finding a common denominator. And we're going to be doing that a whole lot moving forward here when we add and subtract rational expressions, which is what we are going to do next time when we start to look at 14.4. So see you for the next video.